This object in the solar system literally disappeared from scientists' sight and reappeared a week later, always returning to the same place. A satellite with one side bright, almost icy, and the other side dark as coal. And to this day, no one can explain with absolute certainty why it looks the way it does. And then the Cassini probe approached Saturn for the first time. It shows us not just a planet with rings, but a whole world of oddities where the laws of familiar physics seem to start behaving differently. And one of the most mysterious objects in this system is a moon that scientists still call the most contrasting body in the solar system.
Saturn. We learned more about this planet and the objects surrounding it thanks to the Cassini space probe. We learned about the characteristics of Saturn's atmosphere and its ring system. The data about the gas giant's moons also turned out to be important. Iapetus is especially interesting to us. Before Cassini began its mission, we had very little data about this moon. The object is notable for its mountain ridge at the equator and its two-tone coloration. Thanks to recent studies of Iapetus, we've learned that this moon is synonymous with the word contrast. And it's not just about the two contrasting surface colors. What secrets does Iapetus hold? And why is it called the strange satellite of the solar system? Come on. The Italian astronomer Giovanni Cassini observed Saturn through his telescope in 1671. At that time, the scientists saw a small object near the planet. It was orbiting around Saturn. That's how the gas giant's moon Iapetus was first noticed. After some time, Giovanni Cassini would discover other satellites of Saturn as well. But even so, Iapetus remained his most remarkable discovery. When Iapetus was spotted, it was on the western side of the planet. About 39 days later, Giovanni Cassini continued observing Iapetus. He assumed that by this time, the satellite would have already moved to the eastern side. To Cassini's surprise, this did not happen. Iapetus was neither on the eastern side nor on the western side. It was nowhere to be found at all. Can you imagine that? Surely you would be upset because this newly discovered object of yours just disappeared. Fortunately, Iapetus reappeared, but after 79 days. Remarkably, it was exactly in the same place where Giovanni Cassini first saw it. Why Iapetus disappeared for a while remained unknown until 1705. Then Cassini saw the satellite on the eastern side of Saturn using a more advanced telescope. It turned out,
Находясь в этой части, Iapetus имел
by 2 astronomical units of brightness. That is why Giovanni Cassini did not see it on the eastern side when he used another telescope. The scientist understood this, so he continued his research. Before that, he correctly concluded that most likely Iapetus was simply tidally locked to the gas giant, and one side of the object would be darker than the other. This was later confirmed. For this reason, from Earth, it seems to us that the brightness of Iapetus is constantly changing. Iapetus is the third largest of all Saturn's moons. Only Titan and Rhea are bigger. The diameter of Iapetus is about 1,471 kilometers on average. The density is 1.082 grams per cubic centimeter. This is a very small value, considering that it's only slightly higher than that of liquid water on Earth. The composition of Iapetus is dominated by water ice. The distance between the satellite and Saturn is 13.5 million kilometers. This is the greatest distance among the planet's main satellites. Despite all this, Iapetus is in tidal lock with its planet. As we've mentioned several times in previous videos, when a satellite is tidally locked, it always keeps the same side facing the planet. Iapetus's orbit is slightly tilted. Given the distance, you can get a good view of Saturn's rings from the satellite. Let me say a couple more words about the orbital tilt. The tilt angle is 15 degrees relative to the other components of Saturn's system. Why it turned out this way is still not exactly known. In this respect, Iapetus is similar to Triton, Neptune's moon. Unlike Triton, we still don't know much about Iapetus. The composition of Iapetus is actually the same as that of other large moons of Saturn. It is assumed that Iapetus was formed from elements that were moving around a gas giant in its early stages of development. Iapetus's inclined orbit could have formed due to processes characteristic of the early period of the planetary system. The satellite could have migrated due to gravitational interactions with the gas giant Saturn. This is probably what caused Iapetus's orbital shift. At the same time, we do not observe significant distortions in the shape of the orbit. It is actually perfectly circular. This is called low eccentricity. The level of tidal heating experienced by the satellite is quite low. For this reason, there are a lot of craters on Iapetus, because the surface does not smooth out over time. Most likely, there is no geological activity in the inner layers of the satellite's surface. Thanks to Cassini, we got images where you can see some of the huge craters. The diameter of some of them exceeds 350,000 meters. The largest of them is considered to be the crater called Torges, which is located in the dark part of Iapetus. Torges has rims 15,000 meters high. Thus, this crater can be considered one of the largest in the solar system. In your opinion, what is the most remarkable feature of Iapetus? You will probably mention its two-tone coloration, and I can agree with you. This feature makes Iapetus stand out among the other satellites. For a long time, scientists couldn't find answers as to why the color of one region is so contrasting compared to another region. The satellite always faces Saturn with its bright side. If you look from Earth towards Saturn, when Iapetus is in front of the gas giant, we see its dark side. That's why it seems like the brightness level of the satellite periodically decreases. The dark side of Iapetus is called Cassini Regio. However, why the surface of the satellite has such a remarkable coloration remains unknown at this time. It is known for certain that the surface of Iapetus, where the dark side is located, is covered with a layer of carbon dust about 30 centimeters thick. There is a high probability that Iapetus contains organic compounds. It seems that these substances are also present on the surface of comets. There is a theory that the surface of Iapetus is covered by a layer of material from another Saturnian moon, Phoebe. It is located at a greater distance from its planet. Under the influence of sunlight, sublimation can occur on Phoebe, meaning its surface transitions from a solid to a liquid state, and surface materials can move into space. Thus, they could have ended up on Iapetus. This may be the answer to why the moon has a two-tone coloration. However, such processes must occur regularly, since there are not many young craters in the dark part of Iapetus. There is another theory. According to it, the satellite may be characterized by a phenomenon similar to volcanism. Thanks to it, dark materials end up on the surface. The dark coloration may result from hydrocarbon eruptions. This effect is only intensified when the hydrocarbon reacts with solar radiation. A ring of matter also formed around Saturn, which appeared thanks to the moon Phoebe. With the help of the Wide Field Infrared Survey Explorer, WISE, in 2015, we learned that the size of this ring is much larger than previously thought. The size of this object reaches up to about 300 Saturn radii. Based on this data and information from the Cassini spacecraft, a theory was developed about the darkening of one side of Iapetus, which is now considered the most likely explanation. Iapetus is in tidal lock with Saturn, which is why its rotation period is very long. One day on the moon is equal to 79 Earth days. From this, we conclude that the temperature cycle during a day is quite long. Elements on the dark side can absorb heat for a long time and increase the surface temperature. As you know, the reflectivity of the light side is much higher, and accordingly, this side absorbs much less heat. With this much heating on the dark side, volatile substances, including ice, will begin to sublimate. These elements will move to the light side of Iapetus after some time. An additional consequence of the sublimation process is the further darkening of the satellite's dark side, and the contrast between the light and dark sides only increases. That's how we learned more about the interesting coloration of Saturn's satellite. We mentioned at the beginning of the video that Iapetus is considered a strange satellite in the solar system. And it's not just its two-toned surface that makes it remarkable. There is a mountain ridge on the equator which is called the Wall of Iapetus. Its length is about 1,300 kilometers, almost as much as the equator itself. The height of this mountain formation is as much as 13 kilometers. The width, 20 kilometers. If we look at the mountain ridge on the bright side of Iapetus, we'll notice that here it isn't a continuous mountain chain, but rather several mountains alternating with flatter areas. Thanks to the Voyagers, we got the first data about this mountain formation. For this reason, the Iapetus Ridge is sometimes also called the Voyager Mountains. At the same time, scientists still cannot say for sure what factors caused the Iapetus Ridge to form. There are several theories. According to one version, the mountain formation arose as a result of geological activity in the early stages of the moon's formation. At that time, Iapetus had a shorter rotation period and higher surface temperatures. The mountain ridge could have formed from material that came to the surface and then solidified. Another theory says that somehow, years ago, Iapetus absorbed one of the rings belonging to Saturn. The mountain ridge is a buildup of material from that ring. These theories don't end there. There is also a theory that in the past another object collided with the satellite. The collision happened in such a way that the object became a satellite of the satellite. It is assumed that over time, the distance between Iapetus and its satellite decreased, and in an unknown region the object simply broke apart. It left behind a cluster of fragments which formed Iapetus's ridge. This version answers the question of why the mountain formation developed exactly at the equator. Nevertheless, we don't have a definite answer to the question of how Iapetus's ridge was formed. When we received this image, scientists were puzzled about what was depicted in it. Back then, 75 years ago, it was taken by a rocket that had previously been used for bombing cities. It rose to a height of 105 meters, took several shots, and crashed to pieces. But the film survived, and with it came many questions, with more and more answers appearing each year. In this video, you'll find out which planet resembles Van Gogh's paintings, where the first Arab probe was sent, and where astronomers saw a horse's head. Hubble. Even those who aren't interested in space have heard about this telescope. It sends hundreds of photos of planets, star clusters, and space debris to Earth. It allowed us to learn the age of the universe, proved the existence of supermassive black holes, exoplanets, and revealed other facts. Just take a look at its photos. Be warned, they might blow the minds of the unprepared. This image is considered one of the most famous photographs taken by the famous Hubble Space Telescope. Its name, the Pillars of Creation, is no coincidence, as it captures an active star-forming region in the Eagle Nebula. The pillars in the center of the photograph are the result of the movement of charged particles and cosmic wind. At the edges of the mountain ridge, you can see streams of ionized gas flowing out. What do you think is the secret behind the color shades? Each of them indicates different chemical elements. The blue areas have a higher concentration of oxygen, the green ones of hydrogen and nitrogen, and the red ones of sulfur. What do you think of this nebula? The astronomers who first discovered it thought it looked like a horse's head. Although its official name is Barnard 33, many people know it as the Horsehead Nebula. Here it seems as if clouds have moved in and covered the entire sky. In reality, what you see are numerous young blue star clusters, giant glowing clouds of gas, and dark dust lanes crossing Centaurus A. Is there life on Saturn? This mystery persisted for decades until the Cassini probe was sent to explore this planet's hidden corners. Then it became clear that the world around us is enormous. There are almost countless planets in it. And is there really no life out there? Cassini didn't find an answer to this question, but it did become the first artificial satellite of Saturn and passed between its rings. It told us a lot about the Saturn system, and in addition, took a lot of beautiful photos, as many as 323, which was considered a record for a long time. For example, in this image, you can see Saturn's rings illuminated by the sun. Next to them is a small dot. That's our Earth. Or here's another photo composed of 140 images where the Earth peeks out from behind the rings of the giant planet. Looking at it, you realize how tiny we are in the universe. And this photo was taken in 2013 and looks like an illustration for a science fiction movie. What do you think this is? It's just a storm over Saturn's North Pole. Maybe Cassini would have pleased us with more pictures, but its 20-year mission has come to an end. The spacecraft entered the dense layers of Saturn's atmosphere and burned up. Astrophysicists sent it to certain death after it ran out of fuel. Even after the probe's destruction, the last photos it took arrived on Earth. They show the night side of Saturn. The panorama is illuminated by sunlight reflected from the rings of the gas giant. The images were black and white, but NASA added color, and now you can meditate on them. We got the strangest image of Jupiter's moon, which seriously shook NASA and became one of the main discoveries of the entire Voyager mission. It turned out to be a volcanic eruption on Io, which made scientists realize that there are active volcanoes beyond Earth. Overall, the Voyager journey has lasted for more than 40 years, and during this time they have managed to amaze us with other images as well. Get ready for images from NASA's Parker Solar Probe. Compared to the Voyagers, it's a very young traveler that set off into space in the summer of 2018. Its main mission is to study the sun's outer corona. However, on its way to the sun, the Parker probe has already taken a photo of the night side of Venus. The right side of the photo is filled with stars, while the left side is occupied by Venus. The dark spot in the center of the image is Aphrodite Terra, the largest mountainous region on the surface of Venus. The bright streaks in the image are caused by cosmic rays, particles of space dust reflecting sunlight, and particles from the probe itself. The dark spot at the bottom of Venus is an image artifact. The thin, bright area around the edge of the planet may be night glow in the upper layers of Venus's atmosphere, created by oxygen atoms. Next, let's head to Jupiter. Photos taken by the Juno spacecraft will help us with this. They are often compared to the paintings of Claude Monet and Van Gogh, and people with vivid imagination see aliens, dolphins, and dragons in them. One thing is clear: it's impossible not to admire the views we can observe thanks to the JunoCam optical camera. and also that scientists have once again made a mistake. This planet is much more complex and interesting than they thought. Take a closer look at the details in this photo. They are literally unsettling. This is a composite made from several photographs of Jupiter's south pole. In reality, the poles are only half lit due to the slight tilt of the planet's axis of rotation. But thanks to image processing by enthusiasts, we can see the pole in all its glory. This photo gives you goosebumps, but NASA specialists say that this is a common phenomenon for Jupiter, vortex clouds above the planet. Thanks to color correction, the image shows part of the northern temperate belt, a noticeable reddish-orange area located around 40 degrees north in the northern part of the planet. The giant storm known as the White Oval is also visible in the photo, in the area of a series of small cloud regions. The dark regions indicate areas where the clouds descend closer to the interior of the planet. In infrared imagery, these dark regions are hotter than the upper swirling areas. Would you like to take a tour of Jupiter's rings and see them from the inside? But the Juno probe has already been there. Its first ever photograph of Jupiter's rings from the inside really fires up the imagination. It was at a distance of just under 5,000 kilometers and took this photo using a star sensor. Even the background turned out to be remarkable. The upper part of the Orion constellation got into the frame, and the bright star is Betelgeuse. Our next stop is Pluto. A few years ago, the robotic interplanetary probe, New Horizons, was sent there with gifts. In addition to scientific equipment, the spacecraft carries a capsule with some of the ashes of astronomer Clyde Tombaugh, the discoverer of Pluto. There is also a compact disk with the names of 434,738 people who took part in NASA's campaign to send their names to Pluto. 2 coins. Two U.S. flags. A fragment of the first manned private spacecraft, Spaceship One. A compact disc with photographs of the spacecraft and its developers, and a 1991 U.S. postage stamp. This is probably the most famous photograph of our dwarf planet, called Pluto's Heart. It was taken on July 13, 2015, from a distance of about 768,000 kilometers. Pluto doesn't have a very thick atmosphere, but it was still possible to photograph it. And yes, it really is blue. And when scientists received this photograph, they thought they had drunk too much coffee. But then they agreed that there are mountain ranges on Pluto's surface covered with methane snowcaps. And of course, we couldn't ignore Mars. Unlike other planets, there's been quite a line to visit it lately. In just 1 month in 2021, scientists successfully placed the interplanetary station Alya into Martian orbit, the first in the history of the UAE and the entire Middle East region. Soon after, the Chinese orbital probe Tianwen-1 followed, and then NASA's Perseverance rover caught up with them. Tianwen-1 managed to capture images of the southern and northern hemispheres of Mars, and in the photos, they appear in the shape of a crescent. Even though most of the planet is in shadow in these images, they look mesmerizing. The Chinese probe also took detailed photographs where craters, mountain ranges, and dunes can be seen. According to experts, the diameter of the largest crater captured in the image is about 620 meters. The Arab probe Hope also managed to take a panoramic photo of the red planet, which makes you want to examine it in detail. The photo shows 3 shield volcanoes standing in a row and Olympus Mons, an extinct volcano on Mars, which is the highest in the solar system. Astronomers observing the red planet through telescopes on Earth are very familiar with this view, but for satellites near Mars, this is a rare shot. Who knows? Maybe in the near future, one of the countries will manage to establish the first Martian base and go down in space exploration history forever. For now, we can only enjoy beautiful images of planets in space and continue making ourselves at home on planet Earth. For now, we have nowhere else to go. But that's just for now. We are used to measuring distance in kilometers. Tens, thousands, hundreds of thousands. On Earth, that's a pretty normal number, but that's only on Earth. We are just a tiny speck in the vast universe where much greater distances are the norm. What can we say about the universe if even in the solar system we don't measure distance in the kilometers we're used to on Earth, but in astronomical units? One astronomical unit is equivalent to the distance between the Earth and the Sun. If we convert that into kilometers, it's 150 million. For example, Uranus is 3 billion kilometers away from our planet, which is 20 astronomical units. Just imagine the scale of that. And that's far from the limit. Within the whole universe, even astronomical units seem insignificant. That's why we shouldn't use the light year here. 1 light year is equivalent to the distance that light travels in a year, excluding the influence of gravitational fields. For example, Proxima Centauri, the star closest to the solar system, is 4.2 light years away from Earth, and that's actually a tiny distance. So what can we call a huge distance then? And what are larger structural formations like? First of all, let's talk about giant clusters of galaxies. Scientists William and John Herschel were the ones who determined that such structures exist, and they are much larger than other isolated concentrations of galaxies. An important point was that the distribution of such structures in cosmic space was not uniform. In some areas, their concentration was high, in others, extremely low. It happened in the 18th century, but 2 centuries later, scientists had much greater opportunities to understand exactly how galaxy clusters are distributed in space. Thus, we found out that a single galaxy in the universe that is not part of any cluster is rather an exception. Usually, several galaxies concentrate in one area due to the action of gravitational forces. And the next, the largest level, is what are known as superclusters. Their peculiarity is that they can consist not just of a dozen galaxies, but of hundreds, or even more likely, thousands. In such clusters, there is also a concentration of gases with high temperatures. Over time, it became possible to estimate radial velocity from extragalactic redshifts, which meant a more in-depth study of superclusters. Scientists were able to determine the distance to galaxies in this way and model how they are arranged. These were 3-dimensional maps that showed space spanning 1 billion light years. In addition, gamma-ray bursts were especially helpful in discovering supernova clusters. This process itself releases a huge amount of energy. Gamma-ray bursts are mostly characteristic of stars with high rotation speeds located in more distant regions. A greater number of gamma-ray bursts occur in galaxies that are characterized by high levels of activity and where the decay of matter happens more intensely. Scientists studied in more detail how galaxies are distributed and what speeds are inherent to them, which made it possible to find out that superclusters cannot be considered a larger version of ordinary galaxy clusters. Structurally, superclusters are more filamentous and have a high density. Inside such formations, there are systems of galaxies. This can be compared to foam, which in its structure somewhat resembles the arrangement of superclusters. There is no specific shape for such structures. They are extremely varied. They can be walls, like, for example, the Sloan Great Wall, more familiar galaxy clusters, like the Virgo cluster, or superclusters can be in the form of a chain, like the Markarian chain. As we already mentioned, the universe is characterized by inhomogeneity. However, that's not the case everywhere. For example, regions with an area of about 300 megaparsecs can be considered homogeneous. There, galaxy clusters are virtually absent. The clusters themselves are filamentous, with a density about 10 times lower than the average value for other galaxies. Galactic filaments can also form here. Perhaps one of the most famous examples of a wall is the Great Northern Wall. Another name is the Great Wall. It is the largest after the Hercules Corona Borealis Great Wall and the Sloan Great Wall. The average distance reaches about 200 million light-years. The thickness of the Great Northern Wall is 15 million light-years. The length of the structure reaches about 500 million light-years. These are enormous dimensions. But even this is far from the limit on the scale of the universe. For example, the already mentioned Hercules Corona Borealis Great Wall spans 10 billion light-years. And by the way, that's 10% of the diameter of the part of the cosmos we can see. Let's also talk about the galactic wall that is closest to the solar system. It is located near the constellations of Telescopium, Indus, Pavo, Centaurus, as well as the southern constellation Hydra. The galaxies that make up this wall are at least 25 million light-years away from our planetary system. This galactic wall includes galaxy clusters that are also part of the Milky Way. On large scales spanning hundreds of millions of light-years, we perceive the universe as a homogeneous structure where all components are distributed more or less evenly. However, it's important to remember that if we take a region of disturbance, we'll find that the components there are arranged unevenly. We need to know this in order to correctly develop a theory of how the universe evolved. Scientists have developed a three-dimensional model of how galactic structures are distributed in the universe. This helped to discover that from all sides within a range of 1 billion light-years, there are actually clear structures. This means that the distribution of matter in a particular part of the universe spanning a couple of 100 billion light-years will be uniform. That's why we consider the universe as a whole to be homogeneous. Galaxy clusters are the largest structures in the universe, surpassing even galactic filaments, fibers, and galactic walls in size. The process of formation and development of galaxy clusters has its own characteristics. Such structures expand under the influence of the expansion of the universe. However, gravitational forces can slow this process down. Gravitational lensing is characteristic of galaxy clusters and other objects as well. This is an effect where we see a light source distorted if its rays pass through another structure. This indicates a large amount of hidden mass, which most likely comes from dark matter. It is precisely because of it that such galaxy clusters form, since dark matter helps pull matter toward galaxies. Overall, dark matter remains quite mysterious to us. We still don't know a lot about its properties. However, scientists have found out for sure. Dark matter is one of the most important factors in the formation of galaxy clusters. It increases the power of gravity. The main question remains in all of this. Why is the universe not uniform on smaller scales? And here gravitational forces also play a key role. Structures that are evenly distributed simply cluster together under their influence, forming denser regions in certain areas. The very process of matter distribution in the universe began sometime after the Big Bang. The increase in the mass of the universe itself contributed to the fact that the rate of expansion began to decrease. In some regions, the expansion not only stopped but also turned into the reverse process, contraction. This made the inhomogeneity even worse. New clusters of galaxies and voids between galactic filaments began to form. The theory of how galaxies form in the universe today is called the hierarchical theory. According to this theory, in the early stages of formation, there are individual galaxies that later become part of galaxy clusters. These clusters eventually transform into superclusters. Thus, at the final stages of the universe's evolution, the largest structures appear. The thing is, that very homogeneity is characteristic of regions about 300 million light-years across. Based on this, it follows that matter in larger regions is distributed uniformly. However, those same galactic walls themselves are not uniform. For example, the Hercules Corona Borealis wall, and it's actually much larger than 300 million light-years across. Here, we encounter contradictions to the cosmological principle itself. As you can see, not everything about the universe's development is clear to us. Let this be an incentive for us to delve deeper and deeper into the mysteries of the cosmos. This way, we will be able to understand what our universe really is and what our place in it is. And what do you think? How did the large-scale structures actually form? And how will scientists resolve the contradictions associated with this? Take a look at the screenshots currently on the screen. This is statistics from YouTube. What does it mean? Notice that right now, 57% of viewers of this channel are watching without subscribing. This is the true essence of my message to you. So, to make sure Hubble is one of your subscriptions, all you need to do is click on this red button, which looks like this and is located below this video. The law of the universe is simple. Remember that. After all, every subscription from you is very important to me. The more viewers there are, the more often they watch and like the videos, the faster a new super exciting video comes out. Talk to you soon.